Okay, we're going to go over binary subtraction. We briefly talked about before a binary system is something that has just two characters represent something, right? We have either a 0 or a 1. And there's technically place values. So, you can have lots of different place values. We'll make a nice little chart here. Okay, so if we call these the place values, and this would be, the first place value, the second, the third, fourth, fifth. In numbers, this can go on forever. Again, be aware, technically, I'm using a decimal system to represent these place values. The decimal system is what humans are used to reading. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. 10 is technically a 0 and a 1 in the second place value. So with binary, we can either have a 0 in here or we can have a 1. And then once we're counting above that 1, we put a 1 here and we put a 0 in this column, and it's the same thing. Instead of going from 1 to 9 within each column, you have a 0 or a 1. These are the only options, hence binary, like a bicycle, there's just two characters. So, binary subtraction. In binary subtraction, we can set it up the same way we had done our original decimal subtraction. We could be representing something like this. Let's say there's 1, 2, 3, 4, 5. Subtract 1, 2, 3, 1 values, okay? This one is relatively simple. 1 subtract 1 is a 0. That's a character in binary. 1 and a 0 both exist, so we don't have to worry about that. 1 subtract 1 is 0, 0 exists. 1 subtract 0, 0 exists. 1 subtract nothing is 1, and 1 subtract nothing is 1. That's a pretty simple answer to see. I'm going to show it as counters, because when we get into the harder ones, it's going to again be a little easier to use counters. We have 1, 2, 3, 4, 5. So we have 5 place values. 1, 2, 3, 4, 5. There is one counter in each of these. Okay, and I need to subtract. I'm going to use the color red as an anti-counter, or the opposite, okay? So I'm going to use a red in here, a red in here, and a red in here. Those represent the ones we have to subtract. Well, we get a canceling out happening. When there's a black and a red in one of the columns, they cancel each other out, so there are no counters. That would represent 0. That means there would be no counters here, no counters here. Well, there's 1 in there and 1 in there, and we end up at the exact same answer, okay? Let's say now we have to do some type of borrowing. Let's say we have 1, 0, 1, subtract 1, 1. Or even actually 1, 0 to make it a little simpler. Well, when we do the first number here, 1 subtract 0, we already know what that is. Okay. Now, in the second column, I can't take 1 away from 0. So this becomes a little tricky. Okay, and instead of continuing on this, I'm going to do it in the counters, and then I'm going to convert it into our character-based subtraction. It's just, I just don't have a better term for it, okay? So we have 3 place values. We have 1, 2, 3, and we had a counter in the first and a counter in the second. Well, we're going to have an anti-counter in the second one. We didn't have to subtract anywhere else. So here becomes my dilemma. I can't have an anti-counter. I can either have a counter or no counter, because an anti-counter would be a third digit, and this is binary. There's only 2 digits, so it's either 0 or 1. There's no negative 1 here, okay? So let's say in this one, we count down, we'll have 1. Here I have an anti-counter. Well, I need to borrow. So I need to take this counter, and I need to move it over here. Well, when I move it over, it doesn't represent 1. It represents 2 counters, okay? It technically represents 2 different counters in this method. Just like when we were adding, if you recall, when I had counters, and let's say I had 2 counters in here, we would say the 2 of them go over and they represent 1 counter in this column. The same thing happens. This counter on the column to the left, when I move it back, represents 2 counters. So now I can take away a black and a red. How many counters am I left with in that column?
1.
1. How many counters are in here?
0?
0. I've moved this one away. So it's probably good practice once I do that to kind of cross it out so I remember it's gone. So I can put a 0 here, but in all number systems, if there's only zeros to the left of the number system, we don't have to write those in. So really, the answer to this one is just 1, 1. So what does that look like here? Well, here what that means is we borrow this 1, we cross it out, we put the lower value. Remember, we'd always do that with decimal numbers. And when it comes over here, it actually represents the number 2. Okay, I'm kind of using a decimal value in a binary system. I know that's a bit confusing. Or you could represent it as 2 sticks if you want, but think of it as the number 2. What is 2 subtract 1? 1. That's the easiest way for a human to understand that. Again, remember, this is like machine language. They understand everything by like a stick and a 0, a 1 and a nothing. Okay, so let's try one more harder question because it can get even tougher. Okay. What if we have something like 1, 0, 0, 1, 0, and I'm subtracting 1, 1, 1, 1 from this? Okay? What's going to happen here? Well, I'm going to build my counter system again. 1, 2, 3, 4, 5. There are 5 place values. So I'm going to build my little row here. 1, 2, 3, 4, 5. I'm going to put my counters in. There's a counter in the 5th column. And there is a counter in the 2nd column. I have anti-counters in 1, 2, 3, 4 of the spots. Okay, well, let's look at the very first one. Very first one, I have an anti-counter, so I need to borrow. I'm going to take this counter here, move it in here, so it's going to disappear from that spot. I'll have 2 counters. These 2 eliminate each other, and I'm with the number 1. What about here? Well, this is becoming tricky now. I don't have anything, so I'm going to go over here. But there's nothing in the 3rd column either, or the 4th. There's only the 5th column. So I need to borrow a lot. I'm going to take this value, bring it over. It's going to represent 2 in this column, right? Well, I don't need all 2 of them. I need to borrow again. So I'm going to take this value here, move it over. It represents 2 in this column. Great. I still got to get over to the other one. I'm going to take this one here. I'm going to move it over, and it's going to represent 2 in this column. So now I have 2, a counter and an anti-counter. They cancel each other out. I'm left with 1. Here it works out great. Well, I should have crossed these out as I borrowed. I have a counter and an anti-counter, so that's a 0. I have a counter and an anti-counter, that's a 0, and there's nothing left here, that's a 0. So this ended up with the exact same answer as the other one. It's just a 1, 1. So if we were to do this using kind of, let's say, decimal, I would borrow this value here, okay? It becomes the number 2 over here. 2 subtract 1 is 1. Now I'm left with 0 here, so I got to borrow. Well, that doesn't work, that doesn't work. Here we go. I have a 1 here, so that becomes a 2 over here, okay? And then it becomes a... because we have to jump over. Do you remember when we do decimal systems, we have a 0, we put it as a 9 value? Do you remember that concept? The idea of, let's say we have like 105 subtract, 87, let's say. When we borrow here, we usually take from here, this becomes a 9, and then the 1 goes here. You remember that practice of borrowing? Okay, same concept happens here. They didn't put a 10 there, they put a 9, so we don't put a 2 in those spots. Mistake when I did that. We actually put a 1. So when we come across, this becomes 1, this becomes 1, and this one here, where we're trying to add the borrowing, that becomes a 2. That's why I find this a little more confusing than the counter system. 2 subtract 1 still becomes 1, and then 1 subtract 1 is 0, 1 subtract 1 is 0. Okay, so we end up at the same answer. This way I find is a little easier when it comes to that borrowing. Okay?